Okay, so for our deep dive today, we are looking at something that high-resolution models have now fully confirmed.
Right, a sudden stratospheric warming, an SSW, that's set to peak in mid-January 2026.
And our mission here is to really get inside the physics of this and explain why it basically guarantees a major cold snap for North America and Europe.
Exactly. And for everyone listening, you really need to stop thinking of the polar vortex as just, some cold weather.
It's more than that.
So much more. It's this enormous high-altitude spinning system. Think of it like a seasonal reservoir, holding all that frigid Arctic air in one place. And what the data is telling us is that, well, that system is collapsing. The dam is about to break.
That's a powerful way to...
Drivers, we have these huge force multipliers all lining up for the 2025-2026 winter.
So what's first on the list?
First up is the QBO, the quasi-biennial oscillation. It's in its negative or easterly phase.
And that, statistically, doubles the chance of an SSW event?
It does. It basically makes the polar jet stream much more sensitive to disruption.
And what else is pushing on it? I know the Pacific has a big role to play here.
It does. We have a weak La Nina. So if the QBO provides the sensitivity, La Nina provides the brute force from below. It promotes these massive atmospheric waves that literally slam into the stratosphere and trigger the warming.
And all this is reinforced by conditions on the ground.
Exactly. Low sea ice in the Barents and Kara seas helps build high-pressure blocking patterns, and you've got heavy snowpack over Siberia and Canada, which just deepens the reservoir of cold air that's waiting to be released.
Okay, so let's translate this down to the ground for you, the listener. What does this mean for North America?
It means a serious, sustained deep freeze.
We're already seeing extreme cold warnings for parts of Canada, right? The Northwest Territories, Saskatchewan?
Yeah, and the wind chill values are projected to hit -45 to -50 Celsius.
That's literally minutes to frostbite. That's dangerous.
And that same pattern drags that Arctic air deep into the U.S. Below average temperatures from the northern Rockies right across the Great Lakes and into the Northeast.
And Europe's not getting off lightly either. I saw the UK Met Office is tracking the 528 dam line moving south. What exactly is that line?
So the 528 decameter line it's a proxy for air that's cold enough for heavy snow.
Okay.
When you see that line pushing down over, say, southern England, it's a very strong signal for severe cold and snow. We're looking at feels like temperatures in a place like Aberdeen, Scotland, dropping to -8C or even colder.
And here's the paradox that I find fascinating. We're talking about this epic regional cold, but globally, 2026 is still projected to be one of the 4 warmest years on record. How do you square that circle?
It's the classic global warming paradox. As the Arctic warms faster than the rest of the planet, the jet stream, which is powered by that temperature difference, it weakens.
It gets wavier.
Exactly. It gets wavier, it meanders more, and those big meanders allow these pockets of extreme cold to spill south more often and penetrate deeper.
So, bottom line, what does this atmospheric mess mean for, say, our utility bills?
The consequences are immediate. We're expecting the Henry Hub natural gas spot price to average around $4.80 per MMBtu in 2026.
Wow.
And that's being driven directly by this kind of weather. The sustained cold across the U.S. Northeast and Great Lakes just triggers these huge demand spikes.
So the big takeaway here is that the atmospheric barrier is broken. The cold is locked in.
It's locked in, likely until at least mid-February. But, the forecast isn't totally set.
What's the final piece of the puzzle?
The big uncertainty now is how well the stratosphere and troposphere stay coupled. Does the vortex recover up there, or does this disruption lead to a rare final warming event?
Which would end its season early.
And potentially extend this cold weather pattern well into the spring. That's the real question now. That's what you need to keep watching the ensemble models for, to see just how long this thing really lasts.